What is going on, everybody? It's your boy Average Leader here with another video, and today we are tackling number 217, contains duplicate. This question is commonly asked by Apple, Microsoft, and Adobe, and it's a pretty simple problem, and it's going to introduce you guys to a very important data structure. If you guys can go ahead and hit that subscribe and like button, that would mean the world to me. It helps my channel out a ton by giving it more exposure to people that don't know me. And if you want to see another problem done, just comment down below and I'll make sure to do it for you. And with that all out of the way, here we go. Given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. Okay, so let's see. Let's look at the examples that are provided to us. So in example number 1, we see that there's a 1, 2, 3, and another 1. So in this case, there's a duplicate of 1, and since there's a duplicate, we have to return true. But in contrast, if we look at example number 2, there is like a distinct number for each of the elements in the nums array. There's like 1, 2, 3, 4. There's no duplicates at all, so that's why we output false. So when we're looking at this problem, the first things first would be to think of a brute force solution. And if you were given this in an interview, a brute force solution would honestly be something like a double for loop, where the outer for loop would be used to iterate through each of the individual elements. And while we're looking at each of the individual elements, we'd have another inner for loop that would compare each specific element with all the other elements in the nums array. So basically we'd be at 1, and then we'd go through every element of the nums array, and we just keep checking to see if any of the other numbers equals the one that we're at. So here we'd be on 1, and then we'd go to 2, 3, and then the other one, and then we'd see that this is a match, so we'd return true. But we know that this is pretty inefficient. That actually runs in a time complexity of O of n squared. So now we got to think of a way to make our solution more efficient. And usually we could make a more efficient solution by utilizing some extra storage or another data structure of some sort. So here, remember, all we have to do is look for a duplicate of each of the numbers. So a very, very easy way to do that is by maybe putting each of our values into a data structure of some sort. And if we see a value that we've already added to our data structure before, then that's how we know we have a duplicate, right? Now, many data structures have this functionality. It's all about picking the most efficient data structure. So let's just jot down a few data structures that can do something like this. We have the array list, we have the linked list, and we have the hash set. And let's just look at these, just to start off with, okay? So with an array list, anytime, we got to think of the time complexities that we'll get anytime we add to our data structure, and anytime we're checking to see if an element has already been inside of our data structure, or basically anytime we use the contains method. So anytime we add to the array list, that actually is going to be a time complexity of O of n. And anytime we use the contains method, that is also running at a time complexity of O of n. Right? So it's not the most efficient, but it's a great starting point. And we'll quickly notice that many of the time complexities between an array list and a linked list are pretty similar. So the add and contains method in a linked list is also O of n for each. But now let's go to the hash set. A hash set is one of the most efficient data structures to use when it comes down to adding and the contains method. And in fact, it actually runs at an O of 1 add, an O of 1 time complexity for add, as well as an O of 1 time complexity for the contains. So this one really is a no-brainer. The hash set does the functionality that we need to solve this problem. So let's just go through this problem and code out a solution using a hash set. So first things first, what are we returning here? Well, returning a Boolean. So I know that I'm going to have to return true and false at some point. Now, what we're going to want to do here is go through our nums array, and we're going to want to add to our hash set, right? So how are we going to do that? Well, we're going to have to iterate through our nums array, so we can do that with some type of loop. And for our purposes, I'm going to use a for loop. So I'll do for And I'll use a for each loop actually. So I don't need to access each element by their index. I can just access each element. So I'll do for integer, and I'll say num in nums. Nums. And for each number that I'm accessing, I'm going to add these numbers into my hash set. So I'll do, oh, my bad, I didn't even make a hash set. So first things first, let's actually make our hash set. So set, and what's our hash set going to hold? It's going to hold integers, so integer, and I'll call it hash equals new hash set. And there we go. And now, like I said, as we're iterating through our nums array, all we're going to do is add each number to our hash set. So a hash.add num. Okay, dope. Now, we're adding elements to our hash set. Now we need to check if an element has been seen already. So does it make sense to check for this after we add, or should we do it right before we add an element? I think it makes sense to do it right before we add an element so we don't actually need to add that specific element again. Because if we've seen it already, let's just return true and stop iterating through our entire array. So let me code this out and explain what I mean. So before we add to our hash set, we're going to do a quick check. We'll check to see if our hash set contains the element that we're looking for right now. So if hash.contains num, then what are we going to do? That means we have a duplicate, so let's not iterate any further. Let's just return true, because that's what the instructions say. We are going to return true if any value appears at least twice. And if we go through this entire thing and we don't find anything, the last thing we're going to do is return false. So yeah, now let's just look at our code and we'll go through an example. So what I meant earlier when I said, like, should we check to see if our hash set contains a number before we add or after we add? If we were to check if it contains a number after we add, it really wouldn't make sense, because it's just gonna return true to see if the hash set contains that number that we just added. Like, we just added a number, and then now we're just checking to see if the hash set contains that number. Obviously it's going to contain it because we just added it. So that's why we want to check right before we add a specific number to our hash set if we've seen that already. So if we're going through this example right here, we're going to go to the first element in our nums array. So we're going to check, does the hash contain that number 1? No. So it's not going to execute this true. It's going to add it to our hash set. And then now we're going to go to 2. So does hash contain 2? No. So we're going to skip this if, and we're going to go here, and it's going to add 2. Now we're going to go to 3. Does hash contain 3? No. So it's not going to execute this, and it's going to go into this line number 15 and add 3 to our hash set. And finally, we're going to go to this last one. So now we're going to check, does hash contain 1? It does. So it's going to execute this true. It's going to stop. It's not even going to look at this line number 15, because this return has been executed, and we're going to stop. And a very similar pattern happens for example number 2, except since we don't have a duplicate here, this if conditional never gets executed. So now we go completely through our for loop, and at the end we return this false. So there's always going to be a Boolean being returned. So now let's run this code real quick. Perfect. This is working. So let's submit. And boom, look at that, 5 milliseconds, faster than 70% of Java Online submissions. So this is great. Let's talk about the time and space complexity. So the time complexity, since we are iterating through all of the numbers in our nums array, the time complexity is going to be an O of n. And our space complexity, since at a worst case, we're adding elements to our hash set, and our hash set can contain all of the elements in our nums array, at a worst case space complexity, we would have an O of n space. So yeah, guys, that's how you do this problem. It's very straightforward and super easy to do, as long as you know that we need to use a hash set. And notice how we started. We first started with a worst case, a brute force solution where we're utilizing a double for loop. And what did we do? Well, instead of using 2 for loops, we just used 1 for loop. And it looks like the inner for loop is now replaced with this hash set. That's a very common trend you'll notice when you're doing these interview problems. You'll usually have a brute force solution where you have like a double for loop. And if you have to use a hash map or hash set for that particular solution, you'll usually replace the inner for loop with some type of hash set or hash map check, and that's exactly what we did here. So just something to keep in mind for the future. And yeah, this is how you do the problem. So if you guys found any value from this video, go ahead and like the video and subscribe to the channel, and comment down below if you want to see any other problems done. I'll make sure to do them for you. And with that all out of the way, everyone, I'll see you guys next time.